Last time we studied the derivative of f of z, and in which we defined the derivative of a function w. So this is the recall that we defined the w equals f of z to be single valued function of variable z, and then the derivative was defined as dw by dz equals f prime of z equals limit delta z tends to 0 f of z plus delta z minus f of z and whole divided by delta z. But this is valid provided that the limit exists and the delta z approaches 0. We saw that we can have a path like we had here q point and p point, and we wanted to move from q to p in order to make this delta z to be 0. So we may come across many paths, many ways to do so, but it is also possible that while moving on those paths, we may have delta z equals or delta z tends to 0, but it may not means it is also possible that this delta w by delta z is not in existence. So in some ways, in some paths, when you move from q to p, delta z may tend to 0, but delta w by delta z may not tend to 0. So in order to make sure that Hi friends, last time let's recall something what we studied last time. We defined the w equals f of z function, and that was a function which is single valued. Then we defined the derivative of that f of z to be, which is f prime of z, to be delta z tends to 0, and this is how we define the limit, that f of z plus delta z minus f of z divided by delta z. Okay, so this is what we had discussed last time, and so we, in order to make this delta z to be 0, we move from q to p, and here there was a problem in defining this derivative, that so we had shown some conditions that when you can have this derivative to be in existence. So to have this derivative, the limit must exist, and also the value of this derivative should be same on for all the different paths or the ways you have taken while approaching delta z to be 0. So here you may have, so the problem is that you may have some paths, some way from where you can come from this from point q to point p, and in doing so you may reach delta z equals 0, but then this delta w by delta z may not exist on that path. So in order to make sure that while moving on that path, our delta z approaches 0, but at the same time delta w by delta z also exists, we defined two conditions, and they were delta u by delta x, delta u by delta y, delta v by delta x, and delta v by delta y are continuous functions of x and y in region R. And then we define CR equations. Those are Cauchy-Riemann equations, and they are del u by del x equals del v by del y, and del u by del y equals minus del v by del x. So these are the necessary and sufficient conditions for any derivative of the function to be exist. From there, we define the analytic function. The analytic function is a function which is, so the analytic is a function which is single valued and has a unique derivative. So these two were the conditions for any function to be analytic. If it is single valued and it possesses a unique derivative with respect to z at all points in the region R, then such functions are called analytic functions. And to check whether the function is analytic or not, we go on checking CR equations. So CR equations are the necessary and sufficient condition for the function to be analytic. Okay, so this is what we had studied last time, and now as we know the CR equations, we will solve some numericals in order to get feeling that how the questions are asked in the entrance exams. So this was just a recall what we did previously. Now we go to the topic. Now we go to let's take one example, and the question says that check whether f of z equals sine z is analytic or not. So this is what we are asked to check. And this kind of questions are asked in the exams. So we should, since this is the first question, we are taking a simple case. Then we will solve some more 2-3 a little bit advanced level problems. So let us see how to solve this and how to use the CR equations. So first we write this function properly. So we are given f of z equals sine z, but we know that z equals x plus iy. So then this sine z becomes sine x plus iy. Okay, and this is something like sine a plus b. So then you can write this as sine a cos b plus cos a sine b, right? So this is the definition that you are going to use here. So then this sine x plus iy which we have here, that becomes sine x into cos iy plus cos x into sine iy. So then this becomes sine x cos iy is called cos hyperbolic y, right? Plus cos x and sine iy is called I times sine hyperbolic y. So it is I times sine hyperbolic y. I hope you know this, that cos I theta is equal to cos hyperbolic theta, and sine I theta is I into sine hyperbolic theta. This is the definition. So that's how we write. And so this is what we have now. Now you can easily differentiate. So this is your function f of z. Now you can easily differentiate that this term is nothing but u, and then this is v. So now you have this form, f of z equals u plus I v, right? So what is u here? Sin x plus cos hy is u, and cos x sin hy is v. So u is equal to sin x into cos hy, and v is cos x into sin hy. And as we studied that to check whether the function is analytic or not, we have to verify the CR equations. That is what we are going to do. So first let us find out the derivatives. So first let's solve for let's find the derivatives of u. So del u by del x is equal to what? Sin x, derivative of sin x is cos x. So it is, and since this is a partial derivative, so we are taking derivative with respect to x, we will imagine this y terms to be constant. So the derivative will be just respect to this, and this is constant. So cos x into cos x into cos hy. Then what is del u by del y? Sin x will be constant because this is a partial derivative with respect to y. Okay, and cos h will become sin hy. These are the definitions of derivatives. So in case you don't know, you can go through the the formulas, derivations. Then del v by del x is so cos x will become minus sin x. This is constant. And del v by del y, so this is constant, and this cos x constant, and we'll take a derivative with respect to y. So cos x into cos hy. Okay, now let us verify the CR equations. So the CR equation says that del u by del x should be equal to del v by del y. So does it, so do we have that, so does that maintained here? Yes, cos x cos hy equals cos x. So yes, so this is maintained. Then del u by del y should be equal to minus del v by del x. Del u by del y is this, del v by del x is this, and this is a minus of. So yes, this is also maintained. That means this f of z equals sin z. This was the function, right? So this is analytic. This is verified. So this is how we verify whether the given function is analytic or not. Okay, let's take another example, and this is the question from JEST 2015. So this is another example, and it's from JEST 2015. The question says that you have a function f of xy, and that is equal to phi xy plus I psi xy. You are given the phi of xy, and that is x square plus 4x minus y square plus 2y. Okay, and you are given 4 options for psi, and you have to find out which of them is correct. So what we have to do is you have to find out psi xy. So that is what we are going to do here, right? So this is nothing different. It is just like what we write f of z equals u plus iv. So it is just like that. You see here u plus iv. So the structure is same, just the symbols are different. So we'll follow the same rule. You are given u, we have to find v. So you are given phi, we have to find psi. Okay, so we will find the psi xy function by using CR equations. So to do that, let's first find the derivative, the partial derivative of phi of x with respect to x and y. So let's do that. So then del phi by del x is equal to 2x plus 4, and del phi by del y is equal to, so partial derivative with respect to y means x will be constant, so this will be 0, and then this will be minus 2y plus 2, right? Now CR equation says, in terms, now you will write the CR equations not in terms of u and v but in terms of phi and psi. So where you have u, we will write phi, and where we have v, we will write it as psi. Equation are both the relations are still the same. So del u by del x, in the place of that we will write del phi by del x should be equal to del psi by del y, and del phi by del y should be equal to minus del psi by del x. Okay, so this means now we have already found the value of del phi by del x, so that means 2x plus 4 should be equal to del psi by del y, and then this value also we have already, 2y plus 2 should be equal to minus del psi by del x. So to find out psi, we have to integrate on both the sides, so that's how we'll get the value of psi. So here we will integrate with respect to y, and here we will integrate with respect to x. So let me rewrite so that we can do the integration. 2x plus 4 was equal to del psi by del y, and minus 2y plus 2 equal to minus del psi by del x. Okay, so then we integrate with respect to y. Okay, so then we have, here we have 2xy plus 4y plus a constant, but the constant will be the function of x. This is how we define the integration, that when you do the integration with respect to y, the constant will be the function of x, and when you integrate with respect to x, then the constant will be function of y. These are the prerequisites I hope all of us have followed. So I will not get into much details, but in case you have problem in such steps, you may write to me, and if I am capable to answer, I will definitely help you out. Alright, so then here we will integrate with respect to x, so 2y plus 2 dx equals minus psi. Okay, and so we will have minus 2xy plus 2 plus c of y equals minus psi. So we multiply both the side by minus, so we have 2xy minus 2 minus c of y equals psi. So we compare both the sides. Oh, here I made one mistake. 2xy plus 2 dx will be 2x dx. Okay, I hope this is clear. So we combine these both results, then 2xy is common. Okay, here we have 4y, and we had a constant, but I can't write it as a constant, but there was some function of x, and here this is a function of y. So the function of x was unknown, but here this is a function of pure x. So from here we knew that the function of pure x was minus 2, and here we had some function of y, but then from here we already knew that this is the function of y. So we will put some constant now. Okay, so this was not a constant. If I think if I use this constant word, then I correct myself, that when you integrate with respect to y, you have a function of x as the constant term, and then here you have a function of y. Okay, so then we'll have this, and the c will be function of xy. So this is something, and you must be given one of this as the psi in the A, B, C, D option. So you just have to check which matches the answer, then that's the answer. Alright, so this was the question.